Assalamualaikum warahmatullahi wabarakatuh. This is our experiment calibration of Bourdon pressure gauge. This is our team members, Hafiz Izzuddin, Siti Aisyah, and me, Afifah, and also Govindra. Introduction for this experiment, a Bourdon tube pressure gauge is a common pressure measuring device that works on the principle of the Bourdon tube. A Bourdon tube is a metal tube that is bent into a spiral shape where the elliptical cross-section deforms as the internal pressure changes. A pressure gauge is a measuring instrument used to measure the pressure or pressure level in fluid, liquid or gas. Pressure gauges are important for setting up and directing or regulating the fluid power equipment, as well as troubleshooting them. Fluid power system would be erratic and unreliable without pressure gauge. Gauge check that there are no leak or pressure variation that could harm the hydraulic system's working mechanism. Different type of gauge pressure are absolute pressure gauge pressure measuring device, and differential pressure gauge. A Bourdon tube pressure gauge is a type of gauge pressure measuring device which is the most popular device for measuring gauge pressure. This is our objective. The objective for this experiment is to calibrate a Bourdon tube pressure gauge using this weight. And the scope for this experiment, that weight that will be used is 0 kilogram, 0.5 kilogram, 1.0 kilogram, 1.5 kilogram, 2.0 kilogram, and 2.5 kilogram. And weight of the piston that will be used is 1 kilogram. For the theory and working principle, the apparatus is a Bourdon gauge connected to a dead weight tester. The Bourdon gauge has a transparent dial that allows students to see the working mechanism. The mechanism is a thin wall tube with an oval cross-section, and bent into one end of the tube is held rigidly. This end emits pressure. The other end of the tube, connected to a dial and pointer mechanism, is free to move. When the pressure in the tube increases, it tries to straighten and so move the pointer by an amount proportional to the pressure increase. To calibrate the gauge, we add weight to a platform on a dead weight tester. The weight put a known force on the piston. The piston has a known area, so we can calculate the pressure. A flexible tube containing water transfer the pressure on the piston to the Bourdon tube. We add the weight in increments, recording pressure readings from the gauge at each increment. Then they remove the weight and record gauge readings. By working out theoretical results, we can work out gauge error and discuss possible causes.
Hello. Uh, our experiment is the Bourdon pressure gauge. So this apparatus that we use in this experiment. First we have a Bourdon tube pressure gauge. Second we use a dead weight tester. The dead weight tester we use 500 gram, 1 kilo, 1.5 kilo, 2 kilogram, and lastly is 1 kilogram. So the second one is we have the 1 kg of piston. So this step we use to this step for this experiment. First we have to measure the weight of the calibration mass and the piston weight and cross-sectional area. Second, fill the cylinder with oil until it's overflow and gently tap the apparatus to remove any trapped air. Third, we have insert the piston and spin it to reduce the friction. So the next step we have to note the pressure reading from the gauge, and the piston is 0 kilogram, and next add 0.5 kilo, 1.0 kilo, 1.5 kilo, 2.0 kilo, and 2.5 kilo weight in increment, observing the pressure gauge reading at each increment. So after all the load has put in the piston, we must to remove the weight and record the cash reading. So after that, we must to compare the calculate and measure the pressure on the graph. So this is the result for our experiment. We can look here at the mass at the piston kg. So we have at the weight zero. The weight means the mass of the piston, the supply of the piston. After that, we have increment at the weight, uh, which increment 0.5 kilogram. So after we have reading after we have the reading all the that mass we have to remove mass is 0.5 and increment. So after that we can get the pressure from the mass removed from the piston. After we get all the increasing pressure reading, we have to calculate the pressure from the piston. So the pressure from the piston, first we have take the first reading of weight at the piston 0.0 kilogram. So first total mass we have the mass of piston plus mass of weight equal to 0.991. That's mass of piston plus 0, so equal to 0.991 kilo. So the mass that put in the piston is 0.99 kilogram. So after we have the mass, we have to calculate the pressure that applied to the piston. So for the formula of the pressure, we have to mass of the piston, mass that have calculate must to multiply with the resolution of gravity is 9.81. After that, we have to divide the area of the piston. So this here area of the piston here in meter square is 0.000031731. After that we have to multiply by 1000. So we can get the pressure at the piston, the LPC is 13.98 kilonewton per meter square. So after we get the pressure at the piston, the SPC, we have to compare pressure at the piston with the pressure gauge. And after that, we have to calculate the error of calculation. So for this error of calculation, we have to PC minus PT. The SPC is pressure at the piston, and PT is the pressure gauge. That is pressure that is reading in the gauge. After that, we have to divide it with the pressure gauge and multiply with 100. So after we do this calculation, and we can get the error of percentage for first reading is 20%. So after we do all the calculation with the same formula in the fourth slide. So we must to plot the graph that pressure gauge against the cylinder pressure. So we have the two reading, first for the pressure gauge remove and second for the pressure gauge add. So after we get the uh, graph, after we plotting the graph, we have to find the R2, that is a gradient for this graph, and we can get the 0.893.
For the second question, source of error and method to minimize the error, several source of error can affect the accuracy of the Bourdon pressure gauge experiment, but these are can be minimized with proper precaution. Mathematical hysteresis occur with the Bourdon tube did not return to the original state after repeating pressure cycle. This is be reduced by staying with the gauge range and avoiding overloads. Parallel error caused by improper viewing angle can be avoided by reading the pointer perpendicularly. Regular calibrate against a reliable standard ensure accurate reading while maintenance and lubrication of moving parts reduce friction relate inaccuracy. Temperature variability can after reading, so performing the experiment is a controlled environment is the strain. Leaks in the system can lead to error and should be checked with sec- secure connection and leak detector method. Finally, minimize human error through proper training, averaging multiply reading or use digital tools exchange accuracy. By addressing these issues, the experiment reliable can be greatly improved. Okay. The third question, repeatable and accuracy of the experiment. Okay. Repeatable refers to the gauge ability of consistently reproduce the same reading under identical condition. High quality Bourdon gauge typically exhibit good readability, provides they are not subject to mechanical hysteresis, experience wear and environmental functionation. Regular maintenance and operator within the gauge specified range help maintain reliability. Accuracy indicate how close the gauge reading align with the actual or standard pressure value. Bourdon gauge generally have a accuracy range between plus minus 0.1% and plus minus 2% of the full scale reading depending on their type and quality. Accuracy can degrade over time due to mechanical wear, calibration drift, or environmental factors such as temperature change.
So for safety procedure, you have to tie back long hair and avoid wearing loose clothing and jewelry that could cause impingement. Second, wear appropriate personal protective equipment (PPE), including lab coat, gloves, and closed-toe shoes. This equipment safety for our experiment. The pressure gun should be installed perpendicular to the horizontal. Apply the load and never exceed the maximum pressure rating of the gauge. Make sure the air bubble inside the tube is removed by rotating the piston softly before record the reading. That's a step for 3. Make sure the system was stabilized after apply the load to tube reading. And lastly, test the gauge functionality in its operational setting, checking for responsiveness. So before we do the experiment, we want to test the gauge first to make sure the pressure reading is in the good condition and always maintained.
For the conclusion, the experiment successfully calibrated the border pressure gauge, established a reliable calibration curve, and calculated the percentage error. The pressure reading exhibited a linear relationship with applied load, indicate that the gauge responds accurately to pressure change. The observed variation of only 0.5 kg between the up pressure and down pressure reading suggests minimal hysteresis, confirming that the gauge operates with low error. Source of error such as friction between the piston and housing as well as uncertainty in the area of the dead weight tester piston were identified. These were addressed by applying a thin layer of lubricant to reduce friction, while avoiding over lubrication of prevent dust accumulation, which could worsen the issue. Despite this potential source of error, the percentage error of the Bourdon gauge was found within acceptable limit, indicating it suitable for accurate pressure measurement in practice applied experiment, underscore the importance of proper calibration and regular maintenance, ensure the gauge continues reliable and perform in industry setting.